Tom Burggraf is the head of product for AWS Batch. Now, in the way that AWS works, being the head of product basically means you're like the CEO of your own startup, a very well-funded startup with great patient capital so you can dream some really big things and actually implement them, which is why Batch does some of the biggest workloads that we've ever seen in the cloud anywhere. Now, it also means that Tom gets invited into some weird meetings with customers doing some really weird things. And it's not very often that something blows his hair back enough that he comes and says to me, this is the weirdest and coolest thing I've ever seen. And what's really cool is the really amazing developments that the customer has been able to produce. So I asked Tom along here today because when I saw the video and when he showed me what they were doing, I thought everybody has to know about this. Tom Burggraf, welcome to Tech Shorts.
Glad to be here. Thank you so much for having me.
Because AWS is part of Amazon, we do a lot of work with the Amazon, sort of the broader family, you know, the retail store, and, you know, those folks. And a lot of the work that we're doing in there, because we put some features into Batch last year about multi-containers and sidecars and stuff. And so all of a sudden, you're like, it's got a lot of interest in the robotics community. And that was always the intention of some of those features, because we work backwards from some robotics customers to design those. But we do a lot of work with robotics. And then you and I were talking the other day about some robotic stuff. And you were mentioning this Toyota Research Institute story to me. And you were telling me about this. And you showed me the video, and I thought, this is freaking cool. And we'll show everybody the video in a minute. We'll show. We're not gonna like leave you out in the cold. We'll bring it up. But tell us how we got into this thing with TRI, and what is it, by the way?
Yeah, and thank you for that. I'm really excited because this is, without exaggeration, probably the coolest thing that I've had the pleasure of working on, being associated with in my entire career. And
that's high praise, because we get to work on some really weird
shit. We do, and I tell the team all the time of one of my jobs is to tell them what are the amazing things that our customers are doing and how it's changing the world and building the future. And from a product person, that usually sounds like an exaggeration. And fortunately, in the line of work that we're in, it's not. So I firmly believe we are able to help customers do some of the coolest work in the world. So this ranks at the top for me. So backing up, as you said, we've been involved a lot in simulation with robotics and automatic vehicles, especially as of last year with multi-container. And then before that, we've been helping train large language models. So we've trained the large language model that's used for Amazon Search, which also was the foundation for Rufus, which is the first retail LLM, which is really exciting. And we had some feedback from those customers internally of, hey, I love Batch, but I also really love the developer tools of SageMaker training. Can we use those together and have really a fire and forget experience?
Well, because
that became
SageMaker really is where most people are, like designing and building the models, right?
Yes, and the thing is, it's purpose built for that. So their developer tools, the experience with using notebooks and having captive instances, et cetera, is really purpose built for that purpose. And that team is extremely passionate about enabling those workloads. So that the SageMaker AI suite is just a really wonderful set of tools. And one of the things that they didn't have was the ability to set queues in front of it. So why that's important for researchers is they want to be able to submit their jobs and not have to monitor them, retry them. They can take advantage of fair share rules, et cetera. So the idea is that they can spend less time managing the infrastructure and really more time on the research. So for some numbers with this, like internally, one of our search relevance teams that focuses on making sure that our customers actually get relevant results when they search on Amazon.com, they were spending 25% of their time managing just their workload per week. So that equates to about over researcher per year when you pull this out.
Craziness, yeah.
Which is wild. And so they're dedicated. That's awesome. But being able to, not have them check in over weekends or other stuff is something that's there. But they're also dealing with a finite amount of GPUs. So as you know, and as many people know, GPUs are in incredible
you mean
demand.
there's a finite number of GPUs in the world?
There is. And we're building data centers, and it's exciting to see the data centers that are going up from us and just across the world to meet this demand for AI. But it's really important to be efficient with those resources. So whenever you have a commodity like GPUs that are in high demand, you want to make the most of it. And so it's not just throw more machines at the problem, which is a thing that we can do in parallel computing with high performance computing, but making sure that the efficiency goes up. So it's interesting to see these HPC concepts that aren't novel being used for novel applications. And so that's what we ended up doing here. So with Search Relevance, they doubled their GPU utilization using us. And then we went into beta, and one of the beta customers was Toyota Research Institute, or TRI. And so we came to them. This is something they wanted to get higher efficiency to speed up their time, because they couldn't get more GPUs. They wanted to use them more effectively, and they wanted to take a load off of their team, which is great. So we brought them into the beta, and in under a month, it was so impactful for them that they standardized the entire workload for production on this beta, which was less nerve-wracking than I would have expected. It was high praise of, hey, we just want to test this and get your feedback. And the feedback was, this is so helpful for us. We're going to be training our primary workload. And as we started to learn more about this workload, and there was a release earlier this year of a white paper that they put together, which is where this video comes from, we were able to see what the impact of this work was. So they were using it to train a large behavioral model for robotics. And that's an LBM.
So an LBM. So this is something that I don't think I'd actually heard of before. So large behavioral model is really, it stands to reason. This is really, it's an LLM, but for robotic actions and movements and those kind of, I guess, the verbs of robotics, right?
Yes. And the neat thing is it actually takes in natural language for commands. So this is one of the areas of AI that I find particularly exciting outside of kind of the consumer realm of using LLMs to query things and for image creation or document creation or agentic things. This is actually taking those commands into physical tasks within three-dimensional space. But
are those sort of commands, or those sort of, is the language that you're inputting, is that stuff like move hand 3 inches to the left, or is it go and pick up that dinner plate?
It's well, in the what we're going to see is set a breakfast table. And so how this is trained is actually on demonstration. So teledemonstration and video input. So it's tasks that are video inputted and recorded of robot arms doing certain things. So you have a human operator who does those things, and it's broken up into actions of about 1.5 seconds apiece. And so knowing the context of those things, the LBM can actually put that together in a cohesive command of, hey, this is the plate portion of setting the table. This is the dealing with fruit or drinks or whatever, and put it into one cohesive whole.
So it could actually, this is like vibe coding with tableware. Angel's been doing a lot of vibe coding recently, and just the way he describes it's kind of weird. But I mean, the cool thing here is you're saying, okay, I want to set the table. I'm guessing here, I want to set a breakfast table. It needs a bowl for the cereal, a plate for the toast, a cup for the coffee, blah blah blah. Is that the kind of language level that's getting inputted here?
No. So you're literally just doing, like, the prompt is very straightforward of set a table. So the barrier to entry, as you can imagine, for domestic application or normal people, is that they can just say, hey, I want task done and that can be interpreted and executed. So this is really interesting in making it more accessible. And the other thing that makes it more accessible is, in order to update new tasks, that doesn't require additional lines of code. That just requires new demonstrations to be uploaded into the LVM. So this can adapt over time to new things. So if you were to do them, as long as there's demonstration to visualize that, that can be intaken and executed. So if you look at this in terms of the performance over single task baseline, which was one of the ways of doing this previously, it's significantly faster, about 50%, and it's much smoother and more accurate, which is really interesting. So if you want, we can play the video and I can kind of talk through, because it's really interesting to see how this actually works side by side, because it's impressive if you just see it on its own. Seeing it juxtaposed next to a single task baseline was wild.
So let's get it up on the screen. So here it is up on the screen now. And if you're,
let's see if we can play it.
By the way, if you're listening to the YouTube version of this, if you're listening to the podcast version of this, just audio only, we're not going to do a great job of describing what's going on here, but we'll try and give you a summary.
We'll try. So on the left is the single task baseline, and on the right is the LVM. And so the interesting thing here to keep in mind is both of these videos are playing at 1x speed. So we're already, at this point, we're already having the table mostly set by the LVM, and we're only a few seconds in, and it's already progressed to doing the cereal and setting the banana and fruit there. Hasn't spilled the drinks. One of the things that's interesting about the drinks is they are in fact plastic, so they don't have to do a cleanup each time, which I appreciate from a practicality perspective. But you'll see, like, on the single task baseline, it's pouring the cereal right now, and it's really struggling with it. It's already done on the LBM. So everything is much smoother, more refined of, I'm going to find the spoon, I'm going to put it here, I'm going to get these things done. And this is, again, all executed through a simple natural language command on the LBM, set the breakfast table. So that is fascinating. And it's done. It's already done, and we're still struggling with cereal and a banana. And you'll see the single task baseline is just going to sort of give up and be like, I'm going to put the entire fruit bowl on. The entire fruit basket is now going to be there. I have accomplished my goal.
I'm pouring the cereal onto the tray and over the post. And okay.
Right.
Doing
and
it
like,
best, but
on its own, like, a single task baseline is still cool. It's impressive, like, that this can be done but this was the way of doing things.
Now it's pouring this cereal all over the shelf.
Exactly. It's put it down and it's there. But the thing here, if what we're seeing is really a step change in robotics. So it's very much a step change in the progression of where robotics can go and what it has been enabled to do.
And all this stands to reason, right? Japan as a society is aging, right? They have a demography challenge that they're going through, right? They've got a lot of old folks and not a lot of young folks, or at least not a replacement number of young folks coming through to run the economy for them. So they've kind of got this existential need to perfect robotics.
And I think you're going to see, robotics needed stateside, which is where I'm at. We're going to have the largest boom of retirees in the history of our country, with the baby boomers going in. And so domestic applications of this are really interesting. I think we hear a lot about it from Amazon is using it in our distribution warehouses, and we hear a lot about it in terms of battery application or safety aspects. But this starts to make it feel a little bit more tangible and real of how are everyday people going to potentially interact with robots.
I gave a talk at the Nextflow Summit a couple of years ago where I discussed exactly this. This demography problem that most of the developed nations in the world are having, which is we haven't produced enough kids, so we're all going to need some robotics one day. I mean, the robotics is probably the robots are probably going to pick up a lot of the jobs that we just shouldn't have people doing. and they're going to make lives a lot easier. And it also kind of put an emphasis on, the talk I was giving at the time was to a bunch of bioinformaticians. And the reason why it was also very important there is we need those people to be like super productive because, we're not producing enough new scientists to replace the old ones, right? Even though we have the highest educated workforce in generations, we still aren't producing enough research scientists to replace the ones that are going to be retiring in the next 10 or 20 years. So, if we want all those nice life-saving treatments, we actually need the scientists we got now to be super productive, and we're going to keep increasing the productivity of the ones that are coming through. Otherwise, we're going to fall behind. The scientific breakthroughs are not going to happen. So, again, AI is going to have a role to play there, and of course, just augmenting humans so that they're more productive at everything is going to become really important.
I agree, and I think I'm also optimistically hopeful of applications like this in making kind of the dream of automatons become real from sci-fi. Can be inspiring to younger people who are considering what to do with their careers, and making this more approachable, more something that is real and tangible and applicable to their lives to grow that in. And the same thing that's happening with science. I think one of the more interesting areas is the application of AI within the scientific community to accelerate these things. Cool. But I'm so thrilled by this. It's something that feels just, seeing this demo of seeing this is like, this is something that could actually be used, and a foundation for use, whether it's through humanoid robots or robot arms or different things. And doing things that are, as you alluded to earlier, jobs that humans shouldn't be doing. So there's certain types of battery replacement or other things that require fine touch, but can be extremely dangerous. And being able to use robots to do that so that humans aren't at risk to augment those behaviors could be revolutionary, especially when you look into repair and commercial applications. Mm-hmm. Mm-hmm. It's not going to be the same, but if you can have it augment some of those tasks that are highly repeatable, such as laundry or setup of food stuff, you can enable the caretakers to actually scale and
Dude,
focus
if I
on the
could have
things
a
that matter.
robot that did my laundry for me, you just that would actually be kind of cool.
Sure.
I'd be signing up for that. Yeah, this is cool. I like the fact that, this is one of the things that always gets me up out of bed every morning, gets me, motivated about doing my job, is I just love the stuff that we're supporting. It's the workloads that get me excited. It's the weird science we're supporting, the really cool medical cures, the vaccines in pandemics, the astronomy that gets done, just all of it. I love it. And hearing about this sort of stuff, gets me going.
Yeah, it is fascinating, and to be able to contribute to something like this is just so cool, because it's changed my way of thinking how AI can be integrated into our lives beyond just talking to Claude or ChatGPT, and making it really a part of our everyday lives and integrating it into tools that kind of change the way that we live.
Exactly. Now, just on a technical thing, just on a technical point,
sure.
The integration between SageMaker and Batch, what does that realistically mean? What's the thing that we're doing in SageMaker, the service we're providing in SageMaker that's made the difference here?
Yeah. So what we've done is we've actually abstracted all of Batch's queuing capabilities, and we've put them in between SageMaker and the users. So what this means is that, and I kid you not, it's about a 5-minute setup of, as soon as the Batch service environment that's connected to SageMaker is set up, you can have all of those rules for individual queues of retries on certain things. We're building out stuff, but what it does is it abstracts it so that the researchers can just hit this in their notebook. So they can submit the jobs, and the batch queue is a part of that, and it's already set up. So they do not have to manage any of the infrastructure. They can literally have a fire and forget experience. That's the whole thing.
And they never have to leave
the notebook.
They just don't even leave their Jupyter notebook. Everything just
precisely.
That was
the whole
perfect.
Goal. Is you want to be able to use this? You don't want to touch it. Understandable. You're a robotics researcher. You do not have to be a cloud expert. And so, working with the infrastructure and platform managers, we've had just absolutely phenomenal feedback from them. Where their director of information engineering is saying that they've maintained the flexibility and speed while being responsible stewards of their resources. Because
you can be a robotics researcher sitting in your native environment, which is a Jupyter, hacking away on your code, and you can spin up workloads that run out on a whole lot of GPUs and train your model and test your model, and all this stuff can go on inside your Jupyter environment. It's like ergonomically perfect because you never leave that environment. But you're
That's the point.
Being able to do some pretty complex things. I understand. No, this all makes sense. Look, I'm sort of, the job that I got, I watch what you guys are building, and I'm frequently struggling to keep up with the sheer number of things that you're talking about. And this is one of those things where there was just a disproportionate number of people saying, this is freaking cool. We need to pay attention to it. Right.
Which is high praise in an environment that my day will bounce from going through robotics to quantitative trading to bioinformatics to automated vehicles, and this standing out specifically is like it's noteworthy.
Next time, Angel says to me, "You should pay attention to this thing," I've got to listen to that guy more. All right,
so do we.
Tom, thank you for coming in and telling us the story, because this is cool stuff, and I like I say, I get a kick out of hearing what people are doing with our stuff, and I get a bigger kick when it's something really neat like this.
Absolute pleasure. It's a privilege to work on this kind of stuff and to be able to tell a story. So thanks for having me.
Cool.